Hi Math 5-4s. This is the beginning of the video that is for still on week 8. This is the video for Thursday, March 26th for what we would do if we were together in class. Notice there's no warm-ups or time tests for today because we're going to do an investigation. Lesson 100, if you look in your book, Lesson 100 is on page 462. It deals more with geometric solids. There are no practice problems for lesson 100, so you can put a check mark there for complete. There is an activity. I will bring this onto the screen so you can see I'm on page 463 in my book, and there's an activity. If you would like to do that activity, you're welcome to do that. Basically, the geometric shapes that we discussed back in lesson 98, and I'll go back to that to refresh your memory. These geometric shapes, lesson 100 allows you to build those geometric shapes if you would like to. It deals with activity sheets. This is in your test and worksheet book, activity sheets 31, 32, and 33. You can build a cube, a pyramid, and a cone if you would like to do that. Again, that's not anything that I'm going to require you to turn something into me, so that is up to you and your parents. There are no practice problems to turn into me. So that is lesson 100. So, and I talked about all of the details of lesson 100 when we went over lesson 98, the video for lesson 98. So you're not missing anything. It's just a matter of if you want to build those or not. So now I'm going to move on to what we're really going to do today, which is investigation 10. So this video is going to be a little longer because investigations take us some time. Investigation 10 is on page 466. You will need your book to follow along with me. Just like we do in class, we're going to go through and understand it and then answer the questions. So you'll need your book to page 466, and you will need out of your test and worksheet book, this is page 203. Make sure you can see that. It is a activity sheet. Let me move things around so you can see. An activity sheet 34. You will need that for investigation 10 also. And you will need a sheet of notebook paper to write our answers on, and be sure your name is on it, because this is where you'll write your answers. This is what you would turn into me if we were all together, but you will want to write your answers down on it. Okay, those are the things you need to get started with investigation. Oh, I'm wrong. There's something else. If you have dice, you will need, if you just have one, that's fine. You will need 2 if you have dice in your house. So if you could get those items together, that should be everything you would need for investigation 10. Hold on, it says 4 dice cubes. Oh, I know why. Because I'm going to be rolling 2 as the teacher. You're going to be rolling 2 as the student, so that's why your list says 4. But you just need 2 because I have my 2. Okay, so let's get started. You can pause the video and get your stuff if you need, but we're going to get started on investigation 10 on page 466. It is talking about probability. You'll see on page 466 that there is a picture like this. So what probability talks about, or some people call it chance, probability is how likely it is for something to happen. What is the chance that something would happen? So in your book, you have a small version of this spinner. I just blew it up so it'd be easy to see on the video. And we're going to use this spinner to determine some things about probability, about some likelihood that something will happen. So this spinner is divided into what's called a sector. Each of these pieces of the pie, so to speak, are called sectors. If you think of it like when we have a fraction, and if the denominator of our fraction is 6, this circle is divided into 6 sectors. So each sector, if there are 6 of them total, each sector is 1/6 of the circle. Okay? So I'm just writing that so we'll all be on the same page there. 1/6 of the sector. Make sure that fit on the screen. There we go. Okay. So, and the way I determined that again, there are 1, 2, 3, 4, 5, 6 pieces total. So the whole thing has 6 pieces, and each is 1 piece out of the whole 6 pieces. Okay? So what this is doing is you see this arrow piece on it, and that's also located in your book. Basically, it's saying it's a spinner. So someone would flick or push that arrow, and it would spin, 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 and then the pointer end, in this instance, is on B. So that's where it stopped. And round it went and stopped on B. Okay? So we're also going to use the rule that we're going to say there's no way it stops on a line. It's going to have to stop on one of these 6 sections to do this investigation. So let's look at, again, I'm on page 466 in our book. Number 1 says, if the arrow is spun once, what outcomes are possible? Going back to our spinner, if this arrow gets spun 1 time, what are the possible outcomes? Well, we know that each section, is divided up into a letter. So it's either going to land on an A, or a B, or a C. So the only possible outcomes for this are A, B, or C. That's our answer to number 1. That's the only possibilities that it could land on in this page. Okay, is A, B, or C. Okay, number 2 asks us, on which letter is the arrow most likely to stop and why? Well, let's look at our letters here. We have A, so we have A 3 times, we have B 2 times, and we have C 1 time. So it is more likely to stop on an A because there are more A's available for it to stop on. So for number 2, we say it is more likely to stop on A, and the reason is there are more A, that half, if we look at it, half of the circle is covered in A's. So there are more A's. The A's cover half of the circle. Okay? So we would say that it's more likely to stop on A. Okay? Moving on to number 3, it says list the possible outcomes of a spin in order from least likely to most likely. So again, I'm on page 466, number 3, if you're wondering where I'm getting this from. So we want to list them. I'm going to take notes here. We want it to be from least likely to most likely. I'm getting that from the problem, number 3. So, excuse me. If we look at our possible outcomes, we have half of the circle is covered in A's, 2 parts of the circle, 2 out of the 6 are covered in B's, and 1 only is covered in C. So the chances that it stops on a C are the smallest because it has to stop inside this piece right here for you to spin it, and the arrow has to stop right there in order for it to be C. That's a little bitty space compared to the whole circle. And if it's B, it would have to stop. It's got a little bit bigger section to stop in. And if it's A, it's got this whole side over here it could stop in. So that's a lot bigger section. So the least likely place for it to land is in that little bitty section of C. So if I'm going to list it from least likely, my least likely is C. And my most likely, again, I have the most space here, is A. And the one that's kind of in the middle is B. So if I list it from least likely to most likely, the least likely is C, and then B, because it has 2 pieces, and then A, because it has 3 pieces, half the circle. A being the most likely. Number 4, which outcome of a spin is twice as likely as the outcome of C? So we have C here, and we want to know which one is 2 times more likely than C. Well, so we have 1 C, we have 2 B's, so we have 3 A's. Well, 3 would be 3 times more likely than C, so it has to be the letter B. Because 1 section of C, 2 sections of B, twice as much B as C. And it would not be A because there's 3 times as much A as there is C. Okay, number 5. If the arrow is spun, this arrow many times, it's asking, let's see, if the arrow is spun many times, then about half the outcomes are likely to be which of the following? Well, we've kind of touched on that. We have B covering just this little section, C covering that tiny section, and A covers half the circle. So if it's spun many times, half the outcomes are likely to be on A, outcome A. Okay, I'm writing my answers on my sheet of paper. And then I'm moving it out of the way so it's out of the way of the spinner. Okay, for 6, moving on to number 6, still on page 466, if this arrow gets spun many times, spins and spins and spins, what fraction of the spins are likely to stop in sector C? Let me bring the book because it does have multiple choice on this one. So I'm right here. Our choices are 1/6, 1/3, 1/2, or 5/6. Well, when we started talking about our spinner, we talked about the fraction piece for each of these. And the letter C is 1 piece out of 6 total pieces, which when you write that as a fraction is 1/6. So the answer to number 6 is A, 1/6. Okay. Moving on to number 7. If I'm going too fast, feel free to pause the video if you need to write your answers down, okay? Number 7. In 60 spins, about how many times should we expect it to stop in sector C? So let's look at our picture again. We have, if we were to spin this arrow 60 times, about how many times would we expect it to stop in sector C? So we know that sector C is 1/6 of the spins. So we expect it to land in sector C 1/6 of the time. So in 60 spins, 1/6 of the time, or 60 divided by 6, gives us 10. So the answer for 7 would be B, 10 times, about 10 times. We don't know exact because we're dealing with probability. But we would guess that it would be, out of the 60 times, 1 in every 6 is going to be the letter C. So our answer to the problem is B. Choice B, about 10 times. Okay? Now, we're still working on the spinner. And the book is talking about probability. So when we looked at the probability that it would land in sector C, we said it was 1/6 of the time. Probability is between the numbers 0 to 1. Notice 1/6 is a fraction, so it's not a whole number of 1, but it's not 0. It's a part of a number between 0 and 1 for the probability. Okay, so probability is, in this case, between 0 and 1. Now, probability can be 0, and probability also can be 1. For example, when it is something that is certain to happen, that means it is 100% definite, yes, it's going to happen. Okay, so certain to happen. It is definitely going to happen. That probability is 1. When we come over to our 0 side, and that is something that is not going to happen, we say that probability is 0. It has a 0 chance of happening. Whereas over here, if it is for sure it's going to happen, it has a probability of 1, a certain chance that it is going to happen. Let's use that to look at our spinner. On our spinner, what is the chance that it would land, the probability that it would stop on a letter A, B, or C? Okay, let me say that again. What is the probability that it would land on an A, a B, or a C? The probability of that would be 1. Would be 1 that it lands on an A, a B, or a C, because those are our only options. So it is definitely going to land on an A or a B or a C. So the probability is 1. And if I asked, what is the probability that it will land on a K? The letter K. Do we have a letter K up here? No. We have no letter K. So there is 0 chance that that is going to happen. There is not going to happen. So the probability that we would land on a K would be 0. 0 chance of that happening. So let's look at number 8 in the book. What is the probability that the arrow will stop in sector D, and why? So let's look at sector D. Do we have a sector D? No, we do not. So there is 0 chance that it is going to land in sector D. So like down here with the letter K, our probability is 0. There is no sector D to land in. So we can be positive that it is not going to happen. So therefore, the probability is 0. Number 9. What is the probability that the outcome will be one of the first 3 letters of the alphabet, and why? Number 9. So the first 3 letters of the alphabet are A, B, and C. And those are our only options here. So it is definitely going to land on one of those 3 letters. So our probability, just like we talked about here, it is certain that it is going to happen. So our probability for number 9 is 1. And the reason is A, B, and C are the only options to land in. So you know that it is going to land on one of those sections. We know for certain that is going to happen. Okay? Number 10. What is the probability the arrow will stop in sector C? Let's go back. We know it's not 0 because it is going to happen at some point. We know it's not certain that it's going to happen because it could happen at B or it could happen at A. But we talked about sector C here being one piece, one outcome out of the 6 possible outcomes. So we have one outcome out of the 6 possible outcomes. And if we write that as a fraction for probability, it is 1 in 6. Another way to say that is your preferred outcome is your numerator, okay? And your possible outcomes is your denominator. So our preferred outcome here is C. So that's 1, because it's only in one section. But our possible outcomes are 1, 2, 3, 4, 5, 6 possible outcomes. So our answer to 10 is 1 in 6. Moving on to 11, we change from using our spinners to using, calls it a dot cube, a die, because it's solo. So we have a standard die, and if they should have, there's dots on every side, and the numbers, if you're not familiar with that, are 1, 2, 3, 4, 5, and 6 on a die. So we move on to 11, and we're going to be using this to determine. So what numbers are represented by the dots on the faces of a dot cube? Well, I just had said that to you. So if we go through, we know on the dot cube we have 1 dot here, there's 2, there's 3, there's 4, here's 5, and our last possible number on a dot cube is 6. Those are our only possible numbers. If I was to take and roll this, I can only come up, no matter, well, I keep coming up with 6, but no matter how many times I roll it, I can only come up with one of these options. That's it, on one dot cube. So let's look at number 12. If a dot cube is rolled once, which number is most likely to end up on top and why? So let's look back at, we have our preferred outcome over our possible outcomes, okay? Now, Our possible outcomes, we said these on number 11 are the only numbers that are possible if I'm rolling one cube. So I have 1, 2, 3, 4, 5, 6. Okay, so I have something out of 6. And the question's asking me, if the dot cube is rolled once, which number is most likely to end up on top and why? Well, it could be any of them. Every time I roll it, I could get a different number, okay? So, in reality, each one has a possibility of each number, one number out of 6 numbers, has an equal chance of being rolled. There's just as many chances that I roll a 6 as there is that I roll a 2 rolling it, okay? So all of them have equal probability. It's not more chance that I'm going to roll a 4 than there is that I'm going to roll a 2, even though I rolled 2 in a row. Okay, I rolled a 3 there. There's no more chance that I'm rolling a 3 than I'm rolling a 6, than I'm rolling a 1, or any of these numbers. None of them have a higher probability than the other when rolling one dot cube. They're all equal. Okay, so if we move on to number 13, we're still using our dot cube. And it says, if a dot cube is rolled many times, about how often would we expect to roll a number greater than 3? So let's go back to our possibilities. We're going to use these possibilities a lot on number 11. Let's go back to them. These are our possibilities. Out of our possibilities, a number greater than 3 would be 4, 5, or 6. So for our preferred outcome, we would have 3 out of our possible outcomes, and how many total numbers there are is our possible outcomes of 6. So if we look at, there's 3 bigger than 3, greater than 3, and there's 3 that are 3 or less. So half of the numbers are greater than 3. So you would say the answer for how likely, would it be less than half the time? Well, no, because we have 3 over here and 3 over there, 3 on each side of possibilities. Would it be about half the time? Probably so. Would it be more than half the time? Well, no, because we still have 3 greater than 3 and 3 that are 3 or less. So the answer would be about half the time. Okay, number 14. If a dot cube is rolled once, what is the probability of rolling a 7? Is there a 7 on our cube? Anywhere, just rolling one die? No, there is not. So there is 0 chance that we will roll a 7 with just 1. So our probability of rolling a 7, we talked about 0. There is no chance, no probability. It's not a possible outcome. Remember, we said 0 is not possible and 1 is definite. So we know a 7 is not possible. Number 15. With one roll of a dot cube, what is the probability of rolling a 1? Let's go back to our formula. Preferred outcome over possible outcome. Okay, let's look at that. So the probability of rolling a 1. Well, we know the possible outcomes are 1, 2, 3, 4, 5, 6. So there's 6 total possible outcomes. With one roll, what is the probability of rolling a 1? Well, my preferred outcome is one number. It just so happens in this case it's the number 1, but in this there's one number that I'm looking for out of 6 possible numbers that it could be. So my probability is one number, 1 out of 6, or 1 in 6, or 1/6. It's said multiple ways. The probability of rolling one number out of my total possible numbers. 16. How would we describe the likelihood of rolling a 6 with one dot cube? So, rolling a 6, let's look at. Our possible outcomes are still 6, no matter what. We have 6 possibilities when I drop it. Okay, it's going to be a 1, a 2, a 3, a 4, a 5, or 6. Nothing else. And it wants to know the probability of rolling a 6. Well, 6 is one number out of 6 numbers possible. So, is it very likely? Not necessarily, no. It could happen, but you have just the same chance of rolling a 2, a 3, or a 5. Is it just as likely as not? Yeah, that's possible. Or is it unlikely? It's very small chance that you would roll a 6. Just as small a chance as rolling anyone else. So any other number, So the answer is C. It is unlikely. Because you have a very small chance of rolling a 6 with one dot cube. Okay? So we're turning the page. That was 467. Now we're going to 468. Let me clear up the book. Move my stuff there. Okay. So now we're going to get into chance. We've talked a little bit about probability of something happening. Now we're going to talk about chance. The thing that most people are most familiar with chance is rain. We listen to the meteorologist and we hear them say it is 70 degrees and there's a 20% chance of rain. If there is a 20% chance of rain, okay, all our percents have to equal up to 100. So that means there's an 80%, because 20 plus 80 equals 100% chance of no rain. All percents must equal 100% when you are talking with chances. Okay, so if the weatherman tells you there's a 20% chance of rain, that means there's an 80% chance that there's no rain. So most likely, what's more likely to happen? Well, based on that, it's more likely not to rain. Most likely you can leave your umbrella at home. Okay, it's still a small chance you might get a shower on you and get a little wet, but most likely you're safe leaving your umbrella at home. But if the chances were turned and it was a 20% chance of no rain and an 80% chance of rain, in that case, 80% chance of rain is pretty likely. You're going to want to be sure that you have your umbrella or rain boots with you and be prepared. So that is used to predict, the rain chances is used to predict, whether or not it's going to rain. That's where people are most familiar with chance. We see that all the time in the weather forecasts. So let's go on to number 17. Number 17 says, the weather forecast stated that the chance of rain is 40%. According to the forecast, is it more likely to rain or not to rain? So 17, there is a 40%, I like to write everything down so I know what I'm working with, chance of rain. Now I know I have to equal 100, so that means there is a that has to equal 100, and 100 minus 40 gives me a 60% chance of no rain. So, now that I have that written down, let's look at the question again. The weather forecast stated that it's a 40% chance of rain. Is it more likely to rain or not to rain? Well, then I compare my 60% chance to my 40% chance, and my 60% chance is higher. So it is more likely not to rain. So my answer to 17 is that it is more likely not to rain because my chance of no rain is higher. Okay, and 18. The meteorologist said the chance of rain is 80%. This means that the chance it will not rain is what percent? So if I look at 18, whoops, sorry, I think I took it off screen. Okay, so I have an 80% chance of rain. And I know that my percents have to equal 100%. So 100% minus the 80% gives me 20. So I have a 20, I'm going to move that over here, 20% chance no rain. Okay, so then my question says, the meteorologist said the chance of rain is 80. The chance that it will not rain is what percent? Well, I just answered that. 20% chance of no rain. Okay, now we're coming to the part where you're going to need your sheet from your test and worksheet book. This is page 203 in your test and worksheet book. It wants you to put in a prediction. So we're going to be rolling. At this point, you only need one cube. And it wants you to predict how often your outcome, or the number you roll, how often it will be on 36 rolls. So all your predictions have to equal up to 36. Well, we've learned that each number has an equal probability of outcome. So all I did was take my 36 and divide it into 6 pieces. And when I do that, there's 6. My prediction is there's 6 for each one. Okay? So then we're gonna, what you will do, and well, let me explain the prediction part first. So that's that part. So what you will do then is we're gonna roll our cube 36 times. I'm not gonna roll it on camera. I'm gonna pause it and I'm gonna show you and come back. But I'm gonna start so I can show you how to do it. So my number is gonna go under the teacher tally. Okay, so I'm gonna roll my 30, I'm wrong, I am gonna roll my 36 on camera, forgive me. And maybe, we'll see. Okay, we're learning as we go. So I'm gonna roll, and I got a 1. So I'm gonna put a tally mark right there. Then I'm gonna roll, and you can't see it necessarily, but I got a 6. So I'm gonna put a tally mark. There's 2, and there's another 1. And there's another 6. Maybe I'm just rolling 1s and 6s. Oh, there's a 4. So I'm gonna put a tally mark, and I'm gonna do this 36 times, okay? Each time putting a tally mark where it's landing until I get to 36. So I'm gonna pause the video, I'm gonna do that, and then I'll come back and give you my tally.